All
Thank
right.
you.
Thank you. And as we said, I think for those of you that were late, Francisco is launching another stewards group tonight. So it's Lily and me who are basically working here. So be patient and just know that we're doing the best we can too. So, but I wanted to start talking about circles because I think the circle images is something that's really, it's something that's universal. So I think that we can, I'm sorry, 1 second here. Okay. Okay, so I'm sorry. So circle images are universal. You see them a lot of places. I have a few here that are some Native American circle images. Medicine wheels are very important piece of their therapy and help in healing ways. And I think if you think about it, circles appear across cultures, and a lot of the circle images date well before any recorded history. So you think about circles and you think about, I wonder, why circles became so important, besides, a wheel was an important invention, but I think there's also circles help define what cycles are. So we can go to the next slide.
I was going to say, you also have the circle of life.
Right.
And Carolyn, I just want to point out that Kathy had put something in chat about our.
Oh, yep, I see that. Yep.
Just so we can touch it later.
Yep. Thank you.
Okay. Next slide.
All right, next slide. Yep. All right, so this is we talked about Earth cycles and circles and cycles, I think of similarly. And so this is a statement about an Earth cycle from Rachel Carson, who one of her books she wrote was called The Sea Around Us. The most famous book you may have heard of Rachel Carson wrote was called Silent Spring. But and also on the image on the left is a water cycle. So and I don't know, basically, the rain falls, it evaporates, it goes up to the sky, it falls on the ground, it might run into streams, eventually it runs into the ocean. It might get transpired by trees back up to the air. So it's a cycle that goes around and round. And I just want to, I'm just going to touch on some other cycles right now. We go to the next slide. And these are small images, I know, but I'll send you the link so you can look at and learn about it all yourself. The top left picture is the water cycle. The round one in the middle shows the cycle of air in the atmosphere, how air moves about from the colder polar regions to the warmer equator regions. The top right picture is one of the energy cycles. The sun's energy falls on the earth. Some of it's absorbed, some of it is reflected back. The bottom left picture is a nitrogen cycle, how nitrogen's a major nutrient and how that gets moved around the environment. The middle one at the bottom is an ocean water cycle, how warm water, the Gulf of Maine flows up and the cold water flows back down. And the bottom right picture is actually a rock cycle. The earth is filled with tectonic plates, and rocks are created in places and they move out. So I just want to give these things to you as thoughts to think about how there's a lot of cycles and there's a lot of different ways that things move about the earth. And we're going to go to the next slide, which, the big one we're going to be talking about a little bit tonight is the greenhouse gas and carbon cycle. And this is, the greenhouse, there's a lot of different greenhouse gases. Some of them, carbon dioxide is the one you hear about all the time. Actually, methane is an even stronger greenhouse gas, but it doesn't last as long as the atmosphere. And then there's other, fluorinated gases. There's some nitrous oxides. There's other issues, but the biggest 90% of the greenhouse gas problems are either methane or carbon dioxide, and both of those, what they have in common is carbon. So the carbon cycle is this picture here. And rather than me go into details, I have a video we're going to show next. If you go to the next slide, and this is a book. It's a juvenile or youth fiction, nonfiction book about climate change, which I think explains climate change better than almost anything I've seen. So sit back, and we're going to have our bedtime story. No, don't fall asleep though. but it looks. Watch the picture. It's a beautiful book. So enjoy this. Lily, I'm not hearing anything.
Did you share sound, Lily? When you shared the video, you also have to share sound.
Yeah, make sure the little speaker thingy at the bottom of the YouTube is clicked, because I always forget that.
It's also a Zoom feature. When you go to share video, in the bottom left corner, you have to click the box that says share sound.
We also had a problem with the slideshow sharing today too. So hopefully this isn't.
So you had nitrous oxide on the list. I work in the automotive industry, and one of the things we try to reduce is not just nitrous oxide, but oxides of nitrogen, which the heat and combustion can produce different chemicals out of it, different forms of nitrogen.
Lily, are you there?
I'm here.
Okay, so do you think we just move on and skip the video then, or we can watch
What's
it?
wrong?
Oh, we haven't been able to, the video's been, isn't, right now it's
This-
not running, but it
Oh, the
was,
screen share wasn't
there was,
going?
there was no sound for it, and then the screen share
Oh.
disappeared.
Oh, that's weird. Do you want me to just rehook it back up to why didn't the sound come up?
You
What do you
know,
want to do, Carolyn? Just tell me what to
yeah,
do.
why don't, at this point, why don't we, I'll just ask people to watch that movie, because I think it's it's something you'll enjoy watching. It's a beautiful book, has beautiful art in it, and it's what we're sharing is a YouTube video where I think it was probably a learning specialist was reading it out loud to the kids, so she reads the whole thing, and we're just going to read part of it. But I think we'll just skip that and move on, just in the interest of
Okay.
saving time, and if we have time at the end, we can watch it. How's that sound? So I think maybe maybe what we should do right now is take our 5-minute break. So if we want to with that, can you start the slideshow again, Lily?
I'm trying.
Okay.
It's there. It shrunk the screen. Okay. Yeah, it still says screen. I don't know why it did that. Okay, sorry about that.
No worries.
All right, and next slide.
Yeah. All right, so this is, I think we're just going to take our 5-minute break now and stretch. I certainly need to stretch for a minute, and then we'll get back to things. So it's 7:03, so we'll be back around 7. How about 7:10? Does that sound good? And we'll see you then.
Did you stop the recording?
Oh yeah, stop the recording.
Okay, I will do that right now. Next
And
slide.
yeah, before we go on, I wanted to make sure that
Okay.
Ralph had a chance to read this, because I know Ralph Baker is a soil scientist. So this poem was an ode to soil, and soil is something that we have taken for granted for too long, and we're learning a lot about, and a lot more about, and how we have to take care of it, and it will take care of us if we take care of it. So just wanted to say that, but we can go on to the next slide. All right, so we talked about different cycles and things. The earth is also full of different systems as well as cycles. A watershed is an area that contributes rain or snow or runoff to a particular body of water. If you think about you might have a puddle in your backyard. The watershed of that puddle is everything that contributes, that runs off might run off your roof or off your driveway into that puddle. The watershed of the Nashua River includes, a big area. The watershed of the Atlantic Ocean is huge, right? So everything has a watershed. Some are bigger, some are small. The important takeaway is that anything that gets dumped on the land can also seep into the groundwater or run off into a river. So when people might dump a pollutant into somewhere, that can get washed into the water. This is one of the reasons that people who have animals, dogs, should clean up after their dogs and throw it away, rather than let the rain wash the dog poop into the nearest stream, and that goes into the water. So that's just all I want to say there. So we go to the next slide.
You also have sections called vernal pools,
Yep.
which are not running water, but they are very important to the cycle of the water.
Right. They're places, vernal pools are places where groundwater is at the surface for part of the year. So
Very
moving on-
important for tadpoles and salamanders.
Yep. So this slide.
Spring peepers.
Yep. So this slide is it shows you Massachusetts watersheds, and I'm showing this for two reasons. One, I want you to know that there's a lot of different, and these are only major watersheds. So the Nashua is here. The Merrimack is what the Nashua flows into, is a separate watershed on this map. The other thing I want to show you about this map is that this is from a online GIS tool the state provides us, that you can go into and play with if you want to know. And that's the link there on this slide, and I'm sending you the link as well. So once you get the link, you can go in and type your address in, and you can find out where the protected lands are near you. You can find out where you can see property records. You can find out all sorts of different things, transportation networks. It's all there. It's a little bit clunky at times, but it's something, if you were looking for some way to kill time and play around someday, it's a nice way to get to know your area. So we're going to go to the next slide. So what I've done here is I've taken that same map and I scaled it down so you can see the town. So I'm looking at, kind of the north central area where a lot of us are from. And those purple lines are the watershed boundaries. So as you can see, this whole big section is part of the Nashua River watershed. Up in the top left corner, you can see where like Winchendon and Ashburnham are. Ashburnham actually has 3 watersheds. It's kind of a headwater community. So where I live in Ashburnham, the water that falls near me flows into the Millers River and eventually into the Connecticut River. The stuff that flows in the northeastern part of Ashburnham flows up into New Hampshire and into the Sauhegan River, which then flows into the Merrimack up in New Hampshire. So I'm showing you this because, as you can see, there's a line on this map because this is the Massachusetts GIS system, but the watersheds and environmental things they don't see political boundaries, right? They just see natural boundaries. So it's important to remember that, and that people, that if we want to think, get more in tune with the earth and what's happening around us, one way might be to think about, where you live in your watershed, or where you live, where the water falls that lives in your area. So we can go to the next slide. So this is a slide which I found, I just like the graphics of this so well. It could be any pollutant. It could have been, this one happens to be microplastics. It could have been, it could have been, excess phosphorus that would get absorbed by different things. But what this talks about on the left-hand side talks about the sources of microplastics and the ways they come from different places. And then the sinks, where they end up. So like if you have microplastics, are very fine plastic particles that we're finding everywhere in the environment now from years of us, just using plastics, not thinking about what's happening to them, what's going to happen. They flow into, some of them flow into treatment systems. They go through our wastewater treatment systems and aren't removed. They go out into the water. So then a fish might eat the plastic and it gets in their system, and it just it just shows how everything is inextricably intertwined. And I touched on climate grief earlier tonight, and one of my big episodes of climate grief was when I discovered that the microfiber, was using a microfiber, vest in the wintertime, and microfiber clothes. It was warm and fleecy and was fun, but it turns out a lot of those, those fibers when you wash things, they wash out and they wash into the laundry, and then they go down the drain and they go out. So when I realized, whoa, I thought I was doing a good thing by buying, clothes made of recycled fabrics from microplastics, but that everything has an impact, and everything so we have to think about that. It turns out with the microfibers, there's actually a filter you can put in a washing machine that will remove most of the microfibers, but it's not something we require because we haven't decided that that's important for us to do yet as a society. So I just want to bring this, to your attention, how everything's intertwined, and one thing that might seem like it's a good thing might end up having some unintended consequences, and we just have to be really thoughtful about what the possible consequences might be, and then see how we can mitigate them. So we can go on to the next slide. I should actually, let's stop there. We'll talk about, let's go to the next slide, then we'll stop. Touching on ecosystems, that last slide showed you kind of a river ecosystem where things, came into the river and other things took up that pollutant, and things might have eaten the things that took up that pollutant. And this shows you a soil food web where, how things all work together in the soil. So ecosystems are really communities of living things that interact with each other and their physical environment. So, so why don't we just stop right there and just stop the recording for a second so we can. Okay, next slide. All right, so this is something, now again, I'll send you the link so you can look at this map, this very pretty map and much more detailed. I just wanted to let you know that relating to ecosystems and biodiversity, there's something called ecoregions. And so Our ecoregion where we are in this area is, made up of three main areas: the Worcester-Monadnock Plateau region, which is that light blue color, and then there's two areas of some lower land areas, the Lower Worcester Plateau and the Gulf of Maine coastal zone. So these are the kind of the eco zones or ecoregions that make up our area. And ecosystems, the interesting thing about where we are, particularly in the Worcester-Monadnock Plateau region of Massachusetts, is there's a lot of species here that actually tend to live much further north in New Hampshire and Vermont. And so some of the important cold habitats of our region are critical to control the critters that live in these cold habitats. And with climate change, they've found that this has been the biggest issue, that where things, the ranges of animals can change. And so why it's important to talk about biodiversity is the other thing. We're going to talk about biodiversity, and there is a biodiversity crisis, which we're dealing with right now, as well as the climate crisis, and there are things that can be solved together. One of the things, sometimes you might hear people say, well, what does it matter if this animal dies or this plant dies? And it's because it matters because all the living things on Earth, all the ecosystems, they provide different, they call them ecosystem services. Some of them provide food, some of them provide protection from flooding. Everything is all inextricably intertwined. I guess I want you to get out of this slide. And again, I will send you more links. You can learn more about this. The biodiversity crisis, E.O. Wilson has done a lot of work on that. The other person, which I think from what our conversation's just been here tonight that you'll love to learn more about, is Doug Tallamy, who's an entomologist, who's written a couple of books about why it's so important to let native plants, let your lawn go wild, rewild your landscape. Is a whole movement now, and there'll be some links that you can see for that. So next slide. And this is kind of a general environmental science, environmental impact. I just want you to be aware that there are three major ways that people or animals can have pollutants affect them. And one is breathing them in, another is eating them, and a third is like direct contact, like through your skin. And that it's important to know, we talked about watersheds and how one thing in a watershed washes to a particular point. Air quality impacts don't necessarily follow topography like watersheds tend to do. And also air quality impacts can be very different depending on the pollutant and the source. They can be really local, like an odor problem is an air quality problem, right? And you might smell it here, but your neighbor across the street won't smell it. Or carbon monoxide and at intersections, one side of an intersection could have a high carbon monoxide level, the other side wouldn't. And then some of them are more regional. And then we have global things like the greenhouse gas problem is a global issue. So I just want you to take away that everything has impacts, and that what we need to, like the best we can, figure out what they are, who do they affect, and how can we mitigate them. And impacts are almost always very specifically related to particular projects. So don't, beware of generalizations. If someone says, well, this will be fine because it was okay here, it might not be okay. If it was okay in a community in Nebraska, it might not be okay for, Fitchburg. So that's important to know. And then I think the bottom one, I want you to know that, we have set up local, state, and federal laws and regulations so we can reduce or mitigate impacts. And that's an important, people always wonder why, why do you need regulations? It's so we can reduce and mitigate impacts. So next slide.
We also have issues with the radon gas.
Yeah. So, all right, so this, I'm gonna try doing this video. Let's see if this works.
Climate Climate change isn't just an issue for future generations anymore, or for people or animals who live far away. It's already affecting us right here in the places where we live. And the more climate changes, the bigger the impacts we'll see. If you live in New England or the Northeast, you're used to having 4 very distinct seasons: cold, snowy winters, blustery springs, green summers, and colorful falls. But we are already seeing these seasons start to become muddled. Winters are milder, spring is coming earlier, and warming temperatures are changing many of the very things that make the region so unique. Leaf peeping, as they call it, is a multi-billion-dollar tourist attraction, but the peak season is shifting to earlier in the year. And as the mix of trees changes, the colors may not be as spectacular. In the Adirondacks alone, tourism brings in about $1.5 billion a year. But as the lakes get warmer, more algae grows, and lakes filled with green goop aren't exactly fun to swim or boat in. And warmer winters means less snow and ice for skiing and snowmobiling and ice fishing. In Maine alone, snowmobiling brings in over $200 million a year and provides over 3,000 jobs. But the warm winter of 2016 hit hard, and drops like this can be devastating for the economies of many rural communities. Cold winters also keep pests at bay. As winters are warming, ticks are moving north. Some of these are spreading Lyme disease across the region. Others, like winter ticks, don't carry disease, but they do suck blood. Winter ticks are currently killing about 70% of the moose calves born in New Hampshire, according to the state's Department of Fish and Game. One poor moose calf had nearly 100,000 ticks on him when he was found dead recently. The Northeast also has a lot of big cities. Most of these are already covered in concrete, and they don't have a lot of vegetation. This means they get even hotter during extreme heat events, thanks to something called the urban heat island effect. And this affects our health, increasing the risk of sickness and even death, as extreme heat disproportionately affects the very old, the very young, and those suffering from respiratory or cardiovascular disease. Cities with their paved surfaces are also more at risk of flooding, and the risk of the historical 1% heaviest precipitation events across the Northeast has already increased by 55%. It isn't just about what's going on land. The region's coasts support all kinds of fishing and aquaculture businesses, as well as tourism. As sea level rises, the ocean warms, and ocean acidification continues, these are all under threat. Now, the Gulf of Maine is warming faster than most ocean areas, and that is affecting the shellfish and the lobster industry. On the north end, in Maine, lobster harvests are actually booming, as the water has warmed to the ideal temperature for the crustaceans. But south of Cape Cod, the harvests are already collapsing, as the water warms above the level where lobsters can thrive. And experts worry that this collapse could move north as ocean waters continue to warm. And then there's the fact that sea level rise is exacerbating storms, contributing to higher surges that extend further inland, as we saw during Superstorm Sandy in 2012.
All right, I think we'll stop there. So, thank you. Next slide. So that was Catherine Hayhoe, which I've sent you information on, and you can learn more about her global weirding thing, which you'll want to be watching and sending to all your friends. So right now I asked Lily to talk about Discord as a way to communicate in groups. And she's just going to give us a quick walkthrough. It's something that we might do, we might not, or some of us might do. There is a community stewards program that has a Discord server, but I'm just going to turn it over to Lily for this part right now. So go ahead, Lily.
Okay, everybody. I just need to switch screens again. So many screens today. All right, for anybody that is not familiar with Discord, it started for gamers as a way to talk to each other on voice with headsets and things like that during a game so they could keep their hands free. It has now grown into so many communities, and they are set up in servers. And we created one for the North Central Massachusetts Stewards. This is the website for Discord, and there are two ways you can have an account with Discord. There is a permanent one, which is helpful to have the app, whether you do it in your computer or your phone. Some people really hate using Discord on their phone because there's a lot of data that's on the main screen, so it's difficult to navigate. So most people prefer using it on a desktop, but it can be used with a screen. And some people, it doesn't bother them because they're used to dealing with a lot of data on their phone screen. The other way you can get an account is temporarily, and you go through your browser, which is just click on an invite that you've been given to a particular server. And that's, you know, we have the invite in the chat in case anybody hasn't joined or tried this before. And you would basically click on it, it would open it, you know, it'd say open in browser, and you would say yes. And then that account, when you go in, it will ask for a name, but it's not permanent. And it is more private because you're not sharing any data other than the name you give it at the time. But at the same time, you can't keep certain settings because every time you go in, it's a new account. And I'll show you that in a second. All right, now we're going to go into Discord itself. Where are you? There you are. Okay. This is our Community Stewards Discord. And as you can see, there are several columns, like I mentioned. This is the main navigational menu. I am obviously part of a lot of different communities. That's why they all have all these icons. But ours is the one that's up top here. The settings that I talked about, which will include, you know, you can have conversations with friends and things like that, such as over Skype or Zoom. A lot of that can happen through the home button up here, which I'm not going to click on because people's real names are in some of the accounts. And I don't want to compromise, you know, privacy concerns. But you also have settings you can change down at the bottom of the second column. See how it says Lily left the valley? That's my actual handle because I joined Discord as a gamer. And you can change it as well as the icon. And there's three. You can mute yourself, you can deafen your headphones, and then you have user settings here. And it's within the user settings that you see all these options, which also includes things like accessibility, language. You know, if English isn't your native language, you can change Discord so that at least the menus and everything else are in a language you're more comfortable with. They also have settings for notifications. So if you don't want notifications for an entire server, but you do want it for, say, the environmental hub, you can change your settings so that you only get notifications when something's been posted in the environmental hub, as opposed to anywhere on the North Central Massachusetts Steward Discord. And then, you know, you would save your settings afterwards. And it also deals with, you know, voice and video if you're having problems with your headset, and all that kind of stuff is here as well. At any time, if you are having trouble with Discord and you want to be using Discord, you're not just signing up because you think you're supposed to, please either send me an email at comicsgal@yahoo.com or, you know, message me through Discord, which you can do by right-clicking on my name. And nope, that's sorry, not right-click. There's a message, which I can't message myself, so I was kind of silly about that. But you can message. So you can message me directly on Discord saying, help, I can't do this. Why? And I can do that. I can, you know, write back to you. Right now, all of our menus are collapsed because we have quite a few. They're for different focuses. So for the basics, this is just for Discord. I'm not going to go through everything, but I try to leave some relevant information for people who are new and might not be familiar, since we have in the stewards overall a lot of native Spanish speakers. You know, that's why a lot of things you will see will be in both English and Spanish, because we do have heavy representation for people who, although they may speak English that you would never know, they're much more comfortable with Spanish. And so that has the basic info. The intros, please introduce yourself, because people don't know who you are, especially if you come in with a gamer name like I did. And yeah, they could see the Lily part, but they're like, well, is that Lily from my group? You know, this is where you can say yes. And unfortunately, we've had some digressions in here where we started just having general discussions, but people do, you know, say, hey, this is me. and I'm here too. Server discussions specific to the server. Please don't put anything in here unless it's about adding or deleting or where did this go on the server. It just keeps me sane if it's only about that. And then each of the other groups are pretty evident, you know, meetings, discussions, plans, off topic. This is where, if you just want to talk about fruit, talk about it in off topic, please keep me sane. Because right now I'm the only administrator. I have asked people to help moderate. So far, nobody's stepped up. Again, just send me a DM if you're familiar with Discord and you're interested in that. We haven't really needed to moderate hardly anything, but it would be nice just to have somebody else other than me and Francisco, because Francisco's still like, I can't use this. What is this? You have to teach me everything. The location is literally what it is. These are the cities that are served within the North Central Massachusetts Community Stewards. So if you have something that, even if it's not your particular stewardship focus, but it's, you know, focused on Lunenburg, put it here. You know, it doesn't have to be directly to your particular stewardship training that you're doing at any given time. And the hubs, these are primarily set up from actual trainings that have happened, but we've also started adding some like garden because there's been some overlap with other organizations or just general interest like community gardens. So that helps you also if you want to share information or ask questions or say, hey, I recently was contacted by somebody in Gardner that said the skate park, people have been complaining about the graffiti. Maybe we could get some artists to come do murals and then the community wouldn't complain about it. You know, those kind of projects. So they can all go in here. And the information is for stuff that, you know, is just announcements. Obviously, you have an announcement because you have a project coming up. You would remind people there's a special meeting. Like when they had the social gathering, we put that in announcements. Signal boost is if you know of something that other people might be interested in and you don't think that they're going to find about it anywhere else, that's where it goes. And then the rest are just various other resources. You know, if you have long lists of links or email groups people can join and what they're for and so forth. Lastly, the voice channels. The lounge is a general casual chat area. The salon, same thing, but for native Spanish speakers. And then the meeting room, right now we only have one. Why? Because we don't have a lot of meetings on here. But you can do either voice only meetings in the voice channels, and you can also do screen shares on Discord and pretty much set up meetings like we do on Zoom and other mediums. And then of course, Spanish version as well for the same reason, especially because sometimes like tonight, there's an English and a mostly Spanish group going on. I can set up other voice channels. So if you have one that you want to have a meeting at a specific, you know, point, I could just set up meeting room 2 or whatever you want to call it. And you can use that specifically so you don't have to worry about overlapping with another meeting. And it's very much like a lot of things. You just type into the chat, you hit enter. They also have emojis and a lot of other things. But if you would just want to learn the basics, you can, like I said, you can always go back to the Discord info. You can go to the site, you know, see what is involved. But if there's a specific concern you have or trouble you're having in particular, please feel free to email me or send me a DM through Discord and I will help you as soon as I get the notice. Okay.
Great. Thank
I think that was under 5 minutes. I'm sorry if it wasn't.
No, it was good. It just, you know, it's just something you can go in and play with if you want. And we can just figure out, you know, how we might use it. So
yeah, like now I've been posting things like the schedule and when we share the resources.
Yeah. So,
that sort of thing.
Yep.
But you can also come in here into the environmental and say, hey, here's this great link I found about, you know, Watershed Restoration Commission and how they're teaching people for free, which I've been meaning to add in our area, sorts of stuff.
Oh.
Does anybody have questions?
So, and we will send out information, including Lily's email to people tomorrow. So she'll have that. So, all right, why don't we move on to the video?
Okay.
Which is, just want to make sure we can finish in time. So
yeah, I know. I was getting a little worried.
No, I know we were all running late tonight, so it's probably good we didn't.
Okay, and here we are.
So this is the project drawdown video, and it's the second one. We watched the first one last week, so let's go.
Okay, so now we're going to look at how we can stop climate change and achieve what we call drawdown. Stopping climate change is necessary if we want to have a better future, because everything we do is connected back to climate change. Our water, our food, our air, our health, our security, our economy are all connected to what happens to weather and climate. So if we don't fix climate change, all the other things we care about in the future are going to be a lot harder. So we need to address climate change in order to have a better future with a prosperous economy, with resilience, equity, justice, and creativity. All the things we want demand that we address climate change. And that's what we're about. I work for something called Project Drawdown, which is the world's leading resource for climate solutions. We focus on the science we need to know to address climate change and then share it with the world. But why do we use that word drawdown? What does that even mean? Well, drawdown refers to a point in time in the future, and it refers to the greenhouse gas levels in the atmosphere. Now, I remember I told you in the last unit, greenhouse gases have been building up in the atmosphere. Here we are today at the 2020 levels. But then we can choose what happens next. On the path we're on now, we'll just continue to build up these gases, which will just warm the planet more, making the problem worse. But we don't have to do that. We can bend the curve. Bending the curve on climate change means reversing the curve of growing greenhouse gases. And when we hit this point, the little blue dot here, that's the moment of drawdown. That's the moment when greenhouse gases stop climbing and they begin to go back down again into a healthier place. So drawdown is the moment in the future when greenhouse gas levels stabilize and stop climbing, and then they start to steadily decline. And that's when we begin to stop climate change. At Project Drawdown, our job is to get the world to drawdown as quickly, safely, and equitably as possible. So how do we get there? Well, first, we're going to have to learn a little bit of science. It won't be too hard, but it's the stuff we really do need to know to kind of get forward on climate solutions. So first of all, what are greenhouse gases? Well, you've heard a little bit about this before, I'm sure. You know that greenhouse gases kind of let in the sun's heat and they trap the Earth's heat as Earth is radiating out into outer space. So essentially they trap heat. And the more gases means the more heat. And that's why the planet's warming up. Pretty simple. There's a little bit more to it. It turns out that Earth already had greenhouse gases before we came along. There were natural greenhouse gases like water vapor, a little bit of carbon dioxide, and a few other things that have been there for millions, if not billions, of years of Earth history. But then we've got these things we call anthropogenic greenhouse gases, or human-caused greenhouse gases that we've been adding on top of that. And those include more carbon dioxide than was there before, more methane, more nitrous oxide. We've added chemicals that weren't even in the atmosphere before, like fluorinated gases, so-called chlorofluorocarbons, hydrofluorocarbons, and so on, and many other gases that are impacting our climate. And we can actually see how they've been rising over the last 100, 200 years, and especially in the last few decades. We have changed the nature of Earth's atmosphere and added a human greenhouse effect on top of natural greenhouse effect. And that's where we're getting into trouble. So what do these do? It's actually really simple physics. The idea is greenhouse gases are transparent. They let solar radiation, visible light, what we can see, right through them, like just a window. You can see right through it. But in infrared radiation, which you and I can't see, it is opaque. The infrared radiation is what Earth gives off to the rest of the universe, and so it can trap that heat in the atmosphere. It kind of works like this. Imagine a version of Earth with no atmosphere at all, like the moon. It would absorb the sun's radiation and warm up. The sun's heating the ground and the ground would warm up. The ground, just obeying the laws of physics, would also give off heat or infrared radiation back to the rest of the universe, out to outer space. And without an atmosphere, this is what it would look like. The sun's heat comes in, Earth heat goes out, and they'd be in perfect balance, and we'd be at a temperature that would be accordingly in balance with that. But now let's add an atmosphere, a natural atmosphere. So we have what was the natural greenhouse effect. The idea is as Earth is radiating its heat out into outer space, some of it would be absorbed by the air above it, and some of that would then be re-radiated back down towards the Earth's surface. That has the effect of making the Earth's surface a little bit warmer and the upper atmosphere a little bit colder. And that's exactly what Earth has had, and so are mainly all the other planets. Venus, Mars, and others also have a greenhouse effect kind of like that. But then humans come along and we add some more of those gases to the atmosphere. It'd be like adding another blanket on your bed in the wintertime. It traps more heat and keeps you toastier, a little bit warmer, and so on. And so this enhanced greenhouse effect traps a little bit more heat, radiates a little bit more down, and it warms the surface even more. And so far, we've warmed the planet about 1 degree Celsius. That doesn't sound like a lot, but think about it. During the last ice age, the planet as a whole was only 3 degrees colder than normal, and it was a totally different planet. This place was under about a mile of ice, in fact. We've warmed the planet in the other direction by about 1 degree so far, and we're going to keep going. If we keep going to another 2, 3, or 4 degrees, that could be a world we wouldn't even recognize. It would be very, very dangerous for our civilization. So where do these gases come from? Well, I'm sure you've already heard that a lot of them come from burning fossil fuels, right? Burning oil and natural gas and coal and petroleum substitutes and all these things that we have. And that is part of the story. Burning fossil fuels does create CO2, and that causes about 62% of the warming we see on the planet today. So if you forget about everything else, fossil fuels cause more than half of climate change. But that's not all. It turns out that CO2 is also produced by a few other things, including chemistry. In fact, a lot of our industrial processes, especially making cement, releases CO2 into the atmosphere without burning anything at all. It's just kind of industrial chemistry. We also release a lot of CO2 into the atmosphere by burning down trees and deforestation. This green area shows you how much CO2 is caused by burning down forest, which is kind of like burning coal. Coal's dead, trees are alive, but they're both made out of carbon. And you burn them in our atmosphere, you will make carbon dioxide either way. Then we have our next greenhouse gas of methane. Methane is produced by a whole bunch of different things, but the two big sources are agriculture and industry. In agriculture, which is about 2/3 of this methane emissions, is caused largely from cattle. And you've heard all the jokes before, I'm sure, about cow farts. Turns out that's not even true. Cows actually burp methane. They don't fart methane any more than other animals. The other third of this methane comes from industry, especially mining natural gas. Gas wells, fracking, gas pipelines, even coal mines release methane as well. So we have to think about energy and industry and agriculture to look at methane. Then we've got this stuff called nitrous oxide, which a lot of people don't even think about, but it's a big part of our climate change equation. And nitrous oxide, some of that comes from industry, but again, a lot of it comes from agriculture, especially using too much fertilizer or too much manure on our farmers' fields. And finally, we have F gases, or fluorinated gases, which are chemicals we use as refrigerants and sometimes as insulators in industrial processes. And those refrigerants, like chlorofluorocarbons and hydrofluorocarbons, are rising dramatically, and that's why we have to pay attention to this. So putting all those gases together, we emit about 52 gigatons of the equivalent of carbon dioxide into the atmosphere each year. What the heck is a gigaton? It's just a fancy word for a billion metric tons. So we emit 52 billion metric tons of pollution into the atmosphere every year. But there are only 7.5 billion of us. So on average, we're emitting many, many tons of pollution per person into the atmosphere. That's a huge amount. And we're going to talk more about that and how we can cut that down. Another thing we have to notice is that each of these gases works a little bit differently. Some gases trap more heat than others, like methane and nitrous oxide, and those fluorinated gases trap way more heat molecule for molecule than CO2 does. But some gases last longer in the atmosphere than others too, and we got to take that into account. Like methane, we emit today, most of it will be gone within 10 to 20 years. CO2 we emit today will be in the air for centuries and centuries to come. So we have to look at the strength and lifetime of these different gases. In particular, when we think about methane, methane again is that part of the wedge of our whole diagram of greenhouse gases. If we look at the impact of today's emissions on climate for the next 100 years, Methane will cause about 16% of that warming over a 100-year period. But if we look at the next 20 years instead, the role of methane doubles and becomes 32%. So it turns out in the near term, our climate changes are going to be caused by mainly methane and other gases, but in the long term, they're going to be dominated by things like CO2. So which gas we focus on depends a little bit on what time period of climate change you're really most concerned about. We have to look at all of them. Now that we understand what greenhouse gases are and kind of how they work, we're going to look at what regulates the level of those gases in the atmosphere, what makes them go up and what makes them go down. To do this, sometimes it's helpful to think of a bathtub. But imagine a bathtub which we can fill and empty with water. We do that every day, right? Pretty simple. When we add water to the bathtub by turning on the faucet, we scientists call that a source. It's a source of water, and it levels up the water in the bathtub. We can also remove water by opening up the drain, and scientists call that a sink. You'll hear that word a lot about sinks of greenhouse gases. The difference between the sources and the sinks determines whether the water goes up or the water goes down. Sources add and make the water go up. Sinks remove and makes the water go down. Now, if you have a bathtub with the faucet on and the drain open, we have an interesting picture. If the sources are bigger than the sinks, the water level will still go up. But if the drain, the sink, is bigger than the faucet, the source, the water levels will go back down again. So let's take that and apply it to Earth's atmosphere. Well, Earth's atmosphere is basically a big bathtub in the sky. We can fill it with pollution and greenhouse gases, these sources of greenhouse gases, which is largely due to us. And then we have sinks of greenhouse gases, things that pull that pollution out of the sky and put it someplace else. We have sinks on this planet of greenhouse gases, primarily in plants, on land, but also in the oceans. So here's the picture. We put pollution in the atmosphere, nature pulls it out in forests and in oceans. Now, right now, our sources of pollution, the stuff we're putting in the atmosphere, is much bigger than what nature can take out. And that's why the levels are going up. But what if we reduced our pollution? What if we brought it down by a half or so? Well, then maybe nature could kind of keep up with it and pull as much pollution out of the atmosphere as we're putting in. If that were to happen, we would hit that moment of drawdown and we'd stabilize CO2 levels and they'd stay flat. But we can go farther and actually reduce our pollution down to zero and pull more carbon and other stuff out of the atmosphere and actually have greenhouse gases decline and stop climate change and begin to reverse in the long term the damage we've done. So this balance between sources and sinks is what will determine the future of our planet and our climate. Now let's look at the numbers. In today's atmosphere, we see that we actually have about 6 major sources of greenhouse gas pollution. We'll go into them later, but you see electricity and food, industry, transportation, buildings, and other stuff. Then we have nature, which on land and in oceans pull out a total of about 41% of those greenhouse gases, primarily the carbon dioxide part. And that leaves behind 59% of those greenhouse gases in the atmosphere, building up year over year over year. So to achieve drawdown, to get them to reverse and bend the curve back down, we've got to work on both sides of this equation. We can work on the sources and bring them down to zero, kind of turning off that faucet over the coming decades, so there's no pollution there at all. And we can also work with the sinks of carbon, starting with the natural ones that already exist, and make sure they can continue to pull that stuff out of the sky. So the idea of getting to drawdown actually will be based on 3 big principles, and these are important. The first thing we've got to do, and we always need to begin here, is reduce the problem before it even starts. Let's stop pollution before it even gets in the atmosphere so it doesn't cause any problems at all. And that means bringing these emissions down to zero. So we're going to have to zoom in and look at what causes these emissions, what's in the economy, what can we do about it in all of these different sectors, from electricity to industry to agriculture and beyond. And if we do that, we can cause a big reduction in these things and eventually bring them down to zero. So job number 1, stop pollution, bring it to zero. Job number 2 will be working over in the nature space, basically supporting nature's carbon cycle and maybe even adding to it, in the form of sinks. That's the right-hand side of this diagram. We'll have to zoom in here and look on land and oceans about what controls their ability to take up carbon and how can we support that and maybe even augment it, making it stronger in the future. So we've looked at the left-hand side and the right-hand side of that big picture, the sources, the sinks, and we know what to do. But there's a third area we've got to talk about too, and we'll get into this later, is about how, as we improve society, we can do things that aren't about climate change. There's things we should do anyway. But when we improve equality and equity and justice around the world, there are things we do there that actually have major secondary climate benefits. So we might get a twofer of improving human rights and equality and contributing to climate solutions. So working together, reducing pollution, supporting nature, and improving society are the three pillars of our climate solution space. Building on these three pillars and pulling them together all at the same time, we actually have all we need to address climate change in the coming decades. And this is going to be our job over the next few units of this course.
Right. Thank you. Thank you. And I know I want to be mindful that it's 8 o'clock and that some of you have to leave now. I do want you to, for next week, just think about what your environment